phone on already. Yeah. சாப்பிட்டு விடுறீங்களா இல்ல நான் சாப்பிடுறேன் சண்டே போறியா யா வண்டியில 444 24 50 16 22 படிக்க போணுமாப்பா தனியா
Hi students, good morning to everyone. In last class we have discussed about bond parameters. Bond parameters like bond length, bond order, bond angle, bond enthalpy, and resonance. Now we are going to discuss about polarity of bond. Now we are going to discuss about polarity of bond. Mainly in two types of bonds are there. One is a covalent bond and one is ionic bond. The covalent bond can be formed from mutual sharing of electron between two atoms. Ionic bond can be formed from sharing of electron in between opposite charged particles, opposite ions. Now, it is considered partial ionic character in covalent bond. In tomorrow, we will discuss about partial covalent character in ionic bond. In our topic is partial ionic character in covalent bond. Partial ionic character in covalent bond. When a covalent bond formed between two identical atoms, covalent bond formed between two identical atoms. When covalent bond formed between two identical atom. For example, hydrogen bond. The hydrogen bond. In the hydrogen bond formed between two identical atoms of hydrogen atom. Two identical atoms of hydrogen atom. Chlorine, in the chlorine bond. The bond formed between two similar atoms of chlorine atom. Two similar atoms of chlorine atom. In oxygen molecule O2, oxygen double bonded with oxygen. In the fluorine molecule F2, nitrogen triple bonded with nitrogen. So the both nitrogens are identical atoms. Here both oxygens are in the similar atom or the same kind of atoms. The covalent bond formed between two identical atoms of hydrogen, chlorine, oxygen or fluorine. Okay, here both atoms have equal tendency to attract sad pair of electrons. Both atoms have equal tendency to attract sad pair of electrons. Sad pair of electrons. Because of both atoms are identical atoms, that is why both atoms have equal tendency to attract the sad pair of electron towards itself. For example, in hydrogen, the bond with the hydrogen atom, both atoms have equal electronegativity. That is why in this bond break, the bond contains total how many electrons? 2 electrons. One electron move towards here, another electron move towards there. because of both atom have equal tendency to attract or equal tendency to accept sad pair of electrons. Here, in the cloud of electrons are sad pair of electrons. Sad pair of electron. Sad pair of electron lies exactly in between two atoms. Exactly in between two nuclei of atom, two nuclei of atom or nuclei of two atoms. For example, chlorine is a single bond with chlorine. The bond is a covalent bond. The covalent bond formed in between two chlorine atoms by mutual sharing of electron. The chlorine in the bond which contain the two electron clouds. The bond which contain two electron clouds. That electron clouds lies exactly in between two nuclei of chlorine atom. The clouds of electron lies exactly in between in the nuclei of two atoms. However, in case of covalent bond formed between two different electronegativity of atoms. In case of covalent bond formed in between atom having different electronegativity. Atom having different electronegativity. Different electronegativity of atoms. Here, one atom have higher electronegativity than the other atom. Atom with higher electronegativity. Here, atom with higher electronegativity. Higher electronegativity greater tendency to attract sad pair of electron towards itself than the another atom. Greater tendency to attract greater tendency to attract sad pair of electron towards itself then the another atom. Towards itself then the other atom. Itself then the another atom. Here, as a result, the cloud of electron or in the cloud of sad pair of electron. The cloud of sad pair of electron. The cloud of sad pair of electron. Sad pair of electron. The cloud of sad pair of electron get distorted. Get distorted. Distorted is important point. Get distorted. The covalent bond which contains two identical atoms means sad pair of electrons lies in between the two nuclei of atom. Because of the covalent bond formed between two atoms, the covalent bond formed in between two atoms or two identical atoms, both atoms have equal tendency to attract sad pair of electrons. Both atoms have equal tendency to attract sad pair of electrons. Here, in the groups of electron or sad pair of electron lies exactly in between the two nuclei of atom. Suppose with a molecule which contains two different electronegativity, here covalent bond formed in between the two different electronegativity of the atom. Atom with higher electronegativity greater tendency to accept sad pair of electrons. Important points note that atom with higher electronegativity greater tendency to attract sad pair of electrons towards itself, then the another atom. As a result, in the clouds of sad pair of electron get distorted. For example, hydrogen fluoride. Let us consider the molecules of hydrogen fluoride. Hydrogen fluoride. In the hydrogen fluoride molecule which contain hydrogen covalent bonded with fluorine. Here, electronegativity difference between the fluorine and the hydrogens are higher. Electronegativity in between hydrogen and fluorines are higher. Hydrogen fluorines are higher because of electronegativity of fluorine which is equal to 4.0. Electronegativity of fluorine is 4.0 kilojoule per mole. Electronegativity of hydrogen which is equal to 2.1. Electronegativity of fluorine which is equal to 4.0. Electronegativity of hydrogen which is equal to 2.1. So the electronegativity of fluorine is higher than the hydrogen. Electronegativity of fluorine is greater than the electronegativity of hydrogen. So electronegativity of fluorine is greater than the electronegativity of hydrogen. That is why in the fluorine atom, greater tendency to attract sad pair of electron twice than the hydrogen atom. Fluorine atom, greater tendency to attract sad pair of electron. Sad pair of electron twice then that of hydrogen atom. Because of electronegativity of fluorine is greater than the electronegativity of hydrogen. Electronegativity of fluorine which is equal to 4.0. Electronegativity of hydrogen which is equal to 2.1. So electronegativity of fluorine is greater than the electronegativity of hydrogen. So fluorine atom greater tends to attract shared pair of electron two times, twice than that of hydrogen, twice than that of hydrogen atom, because of in the hydrogen fluorine bond is a polar nature. Hence, hydrogen fluorine bond. The hydrogen fluorine bond is polar in nature. Polar in nature. Polar in nature. Hence, hydrogen fluorine bond is a polar nature. In this hydrogen fluorine bond is very small. Hydrogen fluorine bond is very small, equal, and opposites are separated by the small distance. Opposite charge separated by small distance. Opposites are separated by small distance, like 91 picometer. 91 picometer is referred to as a dipole and is referred to as dipole. It is referred by dipole. If the molecule which contain two similar atoms, the shared pair of electron lies exactly in between nuclei of two atoms. If the molecule which contain not identical atom, two different electronegativity of atom means the atom with higher electronegativity is easily accept shared pair of electron towards itself than the other atom. That is why the cloud of shared pair of electron get distorted. The cloud of shared pair of electron get distorted. Let us consider hydrogen fluoride molecules. The hydrogen fluoride molecule which contains hydrogen and fluorine atom. Electronegativity difference between the hydrogen fluorines are higher because of electronegativity of fluorine which is equal to position. Your screen is passing. Electronegativity of fluorine which is equal to fluorine which is equal to 4.0. Electronegativity of fluorine which is equal to 4.0. Electronegativity of hydrogen which is equal to 2.1. That is why electronegativity of fluorine is greater than the electronegativity of hydrogen. Here, fluorine atom greater tendency to attract sad pair of electron twice that of hydrogen atom. Hence, in hydrogen fluoride bond is the polar nature. In the polar nature of hydrogen fluoride bond is very small, equal, and the opposite charge is separated by a distance, small distance which is equal to 91 picometer, and is referred to as dipole. Then, what is meaning of dipole? What is the purpose for using dipole? In the dipole and the dipole movement, it is used to find out percentage of ionic character present in polar bond. Percentage of ionic character present in polar bonds. Dipole movements. Next topic is dipole movements. Dipole movements. What is the meaning of dipole movements? The charge is separated by a distance known as a dipole moment. The dipole moments it is used to find out percentage of ionic character in polar bonds. Percentage of ionic character in polar bonds by using of dipole moments. In addition to that, in the dipole moments also indicate polarity of bonds. So, the polarity of polar bond can be measured in terms of dipole moment. The polarity of covalent bond. Polarity of covalent bond can be measured. By using dipole moments. Dipole moments. The polarity of covalent bond can be measured by using of dipole moments. The dipole moments mathematically expressed as mu, which is equal to Q into 2D, where mu, which is equal to, where mu is dipole moment, Q is charge of atom, then 2D is nothing but distance in between the two charges. 2D is distance in between two charges. Distance in between two charges. 2D is distance in between two charges. It is a dipole moment. Two charges. For example, either more electronegativity or less electronegativity placed in center of the atom. Another A atom present inside. And then B atom placed in that side. In the distance in between the center of the atom to A atom can be considered as one of the mu. In the distance between the center of the atom to B atom can be considered as another dipole moment of mu. It can be expressed as a mu1 is a mu2. The distance in between the both dipole moments of mu1 and mu2. Distance in between the both dipole moments of mu1 and mu2, which is equal to 2D. So, in the 2D, is the distance in between the two charges. 2D is nothing but is the distance in between the two charges. One is a mu1, another one is a mu2. Both mu1 and mu2 are equal. Net dipole moment equal to 0. Both mu1 and mu2 are equal. Net dipole moment equal to 0. Both mu1 and mu2 are equal care net dipole moment equal to 0. Net dipole moment equal to 0. Net dipole moment equal to 0. In the dipole moment can be expressed as a vector quantity. The dipole moment is a vector. Dipole moment is a vector. The direction of dipole moment, direction of dipole moment, is a vector. Direction of dipole moment is vector. Point from vector points. Point from negative charge to positive charge. 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 The direction of dipole moment is vector. In the vector points from negative charge to positive charge. What is the meaning of negative charge to positive charge? The magnitude of dipole moment value is a move from highly electronegative to least electronegativity atoms. The atom having high electronegativity to least electronegativity atoms. It is a vector quantity. The unit of dipole moments. Unit of dipole moments. Unit of dipole moments. Unit of dipole moment is Coulomb meter. Coulomb meter. The unit of dipole moment is Coulomb meter. It is usually expressed is debye units. Debye units. In the conversion of debye units to Coulomb meter, 1 debye which is equal to 3.336 in 10 power minus 30 Coulomb meter. 10 power minus 30 Coulomb meters. So the polarity of bond can be measured by using of dipole moment. In the dipole moment, mathematically expressed as mu, which is equal to Q into 2D, where mu is dipole moment, Q is charge of the atom, 2D is distance between the two charges. The dipole moment is vector quantity. The direction of dipole moment vector points direction from negative charge to positive charge. What is the meaning of negative charge to positive charge? Higher electronegativity to least electronegativity. Higher electronegativity to least electronegativity. So the direction of dipole movement vector points from higher electronegativity to least electronegativity. So negative charge to positive charge. The unit of dipole movement is Coulomb. It is usually expressed as debye units. One debye which is equal to 3.336 into 10 power minus 30 Coulomb. One debye which is equal to 3.336 into 10 power minus 30 Coulomb. Okay. In homonuclear diatomic molecule, in case of homonuclear diatomic molecule, homonuclear, homo means same, nuclear means nucleus, same nucleus of diatomic molecules, two atom contained molecules. Homonuclear diatomic molecules like hydrogen, chlorine, fluorine, nitrogen, oxygen, bromine, iodine, like etc. These compounds all are homonuclear diatomic molecule. Homonuclear, homo means same, nuclear means nucleus, di means two, atom means atomic means atom, molecule means those compound which contain two or more atoms. It is homonuclear diatomic molecule. These homonuclear diatomic molecules have zero dipole moments. These molecules have zero dipole moments. Zero dipole moments. These molecules have zero dipole moments. So hydrogen, chlorine, fluorine, nitrogen, oxygen, bromine, and iodines are homonuclear diatom molecules. In these homonuclear diatom molecules have zero dipole moments because of these molecules all are non-polar covalent molecules. Non-polar covalent. Non-polar covalent molecules. Non-polar covalent. Non-polar covalent molecules. In case of heteronuclear diatomic molecule. In case of heteronuclear diatomic molecule. Diatomic molecule or triatomic molecule. Heteronuclear di or triatomic molecules. For example, hydrochloric acid HCl, hydrogen bromide HBr, hydrogen iodide HI, hydrogen fluoride HF, carbon monoxide CO, nitric oxide NO, carbon monoxide, nitric oxide NO. In water molecule H2O. H2O is a heteronuclear triatomic molecule. Three atoms are there. Triatomic molecule. Remaining hydrochloric acid, carbon, hydrogen bromide, hydrogen iodide, hydrogen fluoride, carbon monoxide, and nitric oxides are heteronuclear diatomic molecules. These compounds are heteronuclear diatomic molecules. H2O is a heteronuclear three atoms are there. Triatomic molecules. Diatomic molecule, triatomic molecules. Okay. In these molecules have non-zero dipole moments. These molecules have non-zero dipole moments. Non-zero dipole moments. What is the meaning of non-zero dipole moments? These molecules have not zero dipole moments. The molecule have some value of dipole moments 1.98 to 1.28, some value of dipole moments, because of in these molecules are polar covalent molecule, polar covalent compounds, polar covalent compounds. In these polar covalent compounds have different kind of atoms are there. In these all different kind of atoms have different electronegativity value. In this different electronegativity value, which is utilized to create the polarity of bond. So it creates the polarity of bond means to form some kind of dipole moment possessed on the molecules. It is a heteronuclear diatomic molecule or triatomic molecules. Heteronuclear diatomic molecule or triatomic. In case of the molecule have polar bond. In case of molecule have polar, the molecule have polar bond, will not necessarily have dipole moments. Will not necessarily have dipole moments. Dipole moments. For example, carbon dioxide, CO2, carbon dioxide. In carbon dioxide molecule, oxygen, double bond carbon atoms are there. In these molecules of linear form of carbon dioxide has zero dipole moments. It is a linear compound. In the linear carbon dioxide molecule have zero dipole moments. Zero dipole moments. But it has two polar covalent bonds. But it has two polar. The carbon dioxide have two polar covalent bonds are there. Covalent bonds. Two polar covalent bonds are there. In the two polar covalent bond, equal magnitude but opposite charge. The two polar covalent bond, dipole moments of covalent bonds are equal. Here, have two polar covalent bonds are there. One is a oxygen double bond carbon, another one carbon double bond oxygen. In carbon dioxide, have two polar covalent bonds are there. In the two polar covalent bond have equal dipole moments. And opposite charge of and opposite direction. Charge of opposite direction. In carbon dioxide, we have two polar covalent bonds. C double bond O, two polar covalent bonds. The two polar bond have equal dipole moment value of magnitude. Equal dipole moment value of magnitude, and it is opposite direction. That is why net dipole moment of carbon dioxide equal to 0. Net dipole moment of carbon dioxide equal to 0. Here, oxygen, double bond carbon, double bond oxygens are there. Already we have learned is a dipole moment is a vector quantity. The direction of dipole moment vector points from negative charge to positive charge. From negative charge to positive charge. Compare the oxygen and carbon in carbon dioxide. Oxygen have a partial negative charge. Carbon have a partial positive charge. That is why here dipole moments is a move from oxygen to carbon in one way, then oxygen to carbon in another way. In the oxygen to carbon can be expressed as a mu1, then oxygen to carbon expressed as a mu1 and mu2. Here, in the dipole moments of mu, which is equal to mu1 plus mu2, mu1 plus mu2. Here, mu1 which is equal to mu1 and mu2 which is equal to minus mu1, because of in this carbon monoxide bond in the vector points starting from oxygen towards the carbon. Another one, in this carbon oxygen bond, the vector points towards from oxygen to carbon. That is why in this oxygen to carbon expressed as a mu1, in this oxygen carbon can be expressed as also mu1, which is equal to mu2, but it is a negative charge. So which is equal to 0. Net dipole moment of carbon dioxide which is equal to 0. Net dipole moment of carbon dioxide which is equal to 0. 0 dipole moments. But in water molecule, can be expressed as a like these compounds: oxygen, hydrogen, then hydrogen. Oxygen is more electronegative than the hydrogen. Oxygen is more electronegative than the hydrogen. The vector points from oxygen to hydrogen one way, then oxygen to hydrogen another way. The oxygen to hydrogen can be expressed as a mu1. Another oxygen hydrogen can be expressed as a mu2, mu1 and mu2. One oxygen hydrogen can be expressed as a mu1. Another oxygen hydrogen can be expressed as a mu2, mu1 and mu2. So the total dipole moments of mu, directed towards upward, downward direction. Directed towards the downward direction. So here in the net dipole moment of water molecule, H2O, which is equal to mu1 plus mu2, which is equal to positive 1.85 debye units. 1.85 debye units. 1 debye which is equal to 3.336 into 10 power minus 30 coulometer. So which is equal to 1.85 into 3.336 into 10 power minus 30 coulometers. 10 power minus 30 coulometers. The next one. In another compounds we have in the dipole moments are there. For example, hydrogen fluoride. Hydrogen fluoride have dipole moment 1.91 in the debye units. Hydrogen chloride, so 1.03 dipole moments. In the H2O 1.85. H2O dipole moments 1.85 debye units. In ammonia heteronuclear polyatomic molecules. Ammonia, nitrogen, hydrogen, nitrogen. In dipole moments, 1.47. 1.47 dipole moments. In chloroform, CHCl3. In chloroform, have the dipole moments 1.04. 1.04. So, electronegativity difference in between the two or more atom increases. Those molecules behave as a polar covalent molecule. The polar covalent molecule must have dipole moments. Must have dipole moments. If the molecule which contain two or more atoms of similar or identical atom present in a compound, the compounds are non-polar covalent bond. The non-polar covalent compounds or non-polar covalent bond have zero dipole moments. Zero dipole moments. Okay. In the percentage of ionic character and polar covalent bond, percentage of ionic character in polar covalent bond can be indicated by using of Pauli method. It is dependent upon electronegativity difference between the two atoms. By using of Pauli method, the Pauli suggests that experimentally gives electronegativity difference between the two atoms which is equal to 1.7. Electronegativity difference in between electronegativity difference in between electronegativity difference is between the two atoms which is equal to 1.7. The value of 1.7 can be obtained from the experiment data. Pauli methods of experiment data. So extent of ionic character or percentage of ionic character in polar covalent bond can be explained by using of Pauli method. The Pauli method gives the for experimental data 1.7. 1.7. Electronegativity difference between the two atoms of XA and XB. Electronegativity of two atoms can be expressed as a XA and X, XA and XB, XA and XB. Here, in the XA bond XB, electronegativity difference between the atom A and B, which is equal to 1.7 means 50% equal to 1.7 means 50% ionic character and 50% covalent characters. When the molecule which contain electronegativity difference in between two atoms of A and B which is equal to 1.7 means those molecules possess 50% ionic character and 50% covalent character. 50% ionic character and 50% covalent character. Suppose if the molecule of electronegativity difference between the atom A and B greater than 1.7, greater than 1.7 means more than 50% ionic character, more than 50% ionic character, less than 50% covalent characters are there. More than 50% ionic character, less than 50% covalent characters are there. Then last one, the electronegativity difference between the atom A and B less than 1.7 means more than 50% covalent character, less than 50% ionic characters. More than 50% covalent character, less than 50% ionic characters. In this electronegativity difference also indicated by Pauli method. So the percentage of the ionic character in covalent bond can be explained by Pauli. Key Exponentially gives you one exponent data 1.7. The electronegativity difference between the atom A and B equal to 1.7 means 50% ion carrier and 50% pollen carriers are there. Electronegativity difference between the atom A and B greater than 1.7 means more than 50% ionic carrier, less than 50% pollen carriers are there. The molecule which contain electronegativity difference between the atom A and B less than 1.7 means those molecules possess more than 50% pollen carrier, less than 50% ionic carrier. Okay, students. Okay, students. Today topic over. The next topic we will meet the next Zoom class. Thank you. Thank you.